In this video we are looking at the integral of sine 2x e to the sine x from 0 to pi over 2, which is a seemingly nasty one, but if you try it, it'll turn out nicely, if you spot a nice trick. If you'd like to give it a try, please pause the video now, otherwise stay with me and we'll look at one possible way of doing it. Alright, still here? Let's do it. Firstly, we look at this sine 2x term here, which seems a bit unhelpful, but actually we know a nice identity for it, because we know that sine of a plus b equals sine a cos b plus cos a sine b, which yields sine 2x to sine x cos x. And then this leads the integral as 2 sine x cos x e to the sine x dx. No more 2x's around. But we have 3 terms. How do we do this? However, we have a sine in the exponent and a cosine in the stem. We'll ignore the other sign for now. But what we know about cosine is that it's the derivative of sine, which is helpful and a useful hint for how we can continue. Take a moment to think how this might be. Alright, so what we're going to do now is we're going to attempt the substitution of u equals sine of x. Now, what we're aiming to do is to simplify the integral, and to do this we have to get our dx isolated and replaced with a du in crude terms. And we're going to first differentiate our u, which is cos x, as we said earlier. Isolating our dx, making the blasphemy of treating it as a fraction, which it isn't, we get dx equals du over cos x, and then we get to 2 sine x cos x e to the du over cos x, which goes down to 2 sine x e to the u du. This sine x is seemingly annoying, but actually it's not that bad, because it's nothing other than our u right here. So we end up with 2u e to the u du. But we had bounds. This is not an indefinite integral after all. Therefore, let's get them. Our original ones were 0 and pi by 2, but these were x bounds. Now our u bounds would be sine of 0 and sine of pi by 2, which are nothing other than 0 and 1, respectively. And this is looking a lot easier already. So now our integral is 0 to 1 of 2u e to the u du. From here, I'll leave you to take 10 seconds to think how we'll continue. Alright, if you answered integration by parts, yes, that's how I am going to be continuing this one. I am sure there are other ways through. However, we'll start with this. Now, with integration by parts, we recall that an integral of the form rv dash equals rv minus vr dash, where r and v are functions of some variable. In this case, we're taking them to be functions of u. Therefore, we must recall that r is being differentiated once, and v dash is being integrated twice, in fact. Therefore, we need to choose a really easy side to integrate. And in this case, the easy part to integrate is the e to the u. Certainly easier to integrate repeatedly. So we're going to take r equals 2u, r dash equals 2, obviously, v equals e to the u, so therefore our I is equal to nothing other than 2u e to the u minus the integral of 2e to the u du from 0 to 1. Now, this leads us to 2u e to the u minus 2e to the u, which is 2u minus 1 e to the u. And after a little bit of substitution, you will get to 0 minus minus 2, which is 2. And at that, we have the value of our original integral. Let's have some moment of celebration. Yay. 2. If you've got to this point in the video, thank you for watching. I hope this was of great help to you, and I hope to see you again soon. Have a good one.